answers really quickly for those of you guys that might still need to check it tonight because I realized I wasn't recording. But as I get that ready, let's go ahead and talk about number 35, which is one of those weird ones, those funny ones. But it wasn't really funny because they actually just said go into standard form. So let me get back to number 35. There we go. So to get into standard form, all you actually have to do is multiply that 9/4 by what is cosine of 3 pi over 4 and what is sine of 3 pi over 4, which, I mean, normally you would have to pull out of the unit circle, right, guys? But this is the physicsy chapter, so what do you get to actually use on the test tomorrow? Calculator for the whole thing. Which means, do you have to make your brain work super hard on something like, oh, it didn't freeze for you? Weird. It like unfroze and then froze again. I hit the zoom button. That's what's weird. Oh dear. How do I zoom out? Nope, wrong way, wrong way, wrong way, wrong way, wrong way. Okay. All we have to do is really just multiply in, but since you guys are going to have your calculators tomorrow, here's just something I'm going to do a quick heads up on. What mode should you be in? Radian mode, right? But long story short, when you're actually solving this 9/4, since I do know what this is, it's cosine's a negative root 2 over 2, and sine's going to be a positive root 2 over 2. I could go ahead and do it pretty quickly. You guys could get decimals and compare tomorrow. But we're going to end up with negative 9 root 2 over 8 plus 9 root 2 over 8. Okay. This one wasn't too bad. And then you were supposed to graph it, and 3 pi over 4, hopefully we could get in the second quadrant. We're like, yay, there he is. But just talking about what you guys were saying about the tangent inverse and how it only sometimes works, if you were to try to go backwards to this guy or from this guy, and you would do tangent inverse of b over a, so you would take your whatever over 8. Your calculator would actually give you negative 45. Or in radians, it'd give you negative pi over 4. Is that right? Look at your picture. So if you're trying to find a theta, look at your picture and say, ooh, nope, negative 45 doesn't get me where I want to go. But pause. Is it telling you what it can? Yes. So if it's telling me here, then how do I get over there? Add 180. The symmetry of these angles is beautiful because then you can say, okay, well, it's not where I want it to be, but I can just add 180 and get there. So this would be an example where the calculator would spit out something that's actually totally wrong in the sense of in the wrong quadrant, but the symmetry is right. I just need to get over to the other side. And so I'm going to go ahead and would need to, if I needed to get back from this standard form to that trig form, into my formula b over a, I would need to add 180 to get that, or add to this guy, add pi to get my 3 pi over 4. Those are the two different times that tangent inverse doesn't work. Cool? Kind of. Okay. Yeah. Yeah, sure, that's fine. And remember, this wasn't the point of this question, so like you wouldn't have done it in homework on number 35. It's more of just me trying to warn you when tangent inverse is fun. And that's actually you guys had like you had this even number 28. Anyone watching the video grading, just pause it because I'm not going to stay on this for long. And then you had number 70. Final answer is negative 32. Pause if you need to look at it longer. But you guys also had these guys that were the weird fractional people from notes yesterday. So I'm going to go ahead and pull up an example of that, which is number 83. Okay? So you guys can totally be in your homework spiral. You can totally work this out with me if you want. Some of you actually figured out how to do it using examples from the book. And so if you did that, if you want to go grab a textbook and play with review problems, I don't mind. Grab a textbook, or if you have one at your desk, you can do that also. But for those of you guys that, you know what, I didn't know how to do this one, I'm going to go ahead and actually steal this guy as the example in our notes. The actual homework problem, I'm stealing him to be the example in our notes. And I'm going to dual page it with the page before, which is where the formula is found. So what we didn't get to yesterday was anytime you see some sort of nth root of somebody, it's really x to the 1 over n. So whenever, like in this one, they said, hey, we want this guy who's z, we want the cubed root of him. The cubed root of anything is actually z to the 1/3. And so we can actually use de Moivre's theorem just like we did for whole powers. Because de Moivre's theorem says if you have a z to the n, just go ahead and raise the r to the n, and then go ahead and do your cosine of n theta plus I sine of n theta. That's what de Moivre said. So in this one, if we're going to do the 1/3 power, we're going to do 8 to the 1/3 times cosine of 1/3 times 2 pi over 3 plus, now, I'm running out of room. But if it was this easy, I could have totally showed this to you at the very end of yesterday and been like, no stress, you guys should be fine. Just change the cubed root to a 1/3 and you're done. But it's a little bit harder than that because, like we saw with multiple angles, guys who are whispering, I didn't allow for that. But you can be working on the review quietly. When we start reducing or dividing angles, we actually also have to consider their coterminal angles. And that's what the note was right here, which I also included the link in your Google Classroom if you guys noticed that you could have gone and watched me do examples of the fractional powers to help you in the end of homework, right? You can't just do the 2 pi over 3 because actually, remember, anytime there's an angle, there are all these coterminals that also land on the same spot. So ironically, we can't just do the 1/3 times 2 pi over 3. We're going to add a little piece, and that's what the end of notes say right here. Whenever we have fractional powers, we actually don't just multiply, which for roots you're going to end up dividing the angle, but also the angle and its coterminals. So I'm going to do 1/3 times 2 pi over 3 plus 2 pi n. I need to also include his coterminals. Plus I sine of 1/3 2 pi over 3 plus 2 pi n. Ugh, sorry. Ran out of room there at the end. Now, 1/3 power of a number is the cubed root. So I'm going to rewrite that because that makes my brain hurt a lot less. And then when I go ahead and multiply in, I'm going to get cosine of 2 pi over 9 plus 2 pi n over 3 plus I sine of plus 2 pi over 3. The dealio that kind of makes this last step a little bit easier. When we're trying to find the nth roots, which in this one is the cubed roots, which means when n equals 3, the 3 is inside the root, we're going to go ahead and use however many k we need to get up to this number. So starting at 0, I'm going to use 1 and 2 and 3 of the k's. So 0, 1, and 2. I need 3 numbers. Starting at 0 every single time. So you're always going to end basically 1 less than the root, which is what this little formula says, to get your answers. And so when I keep on going, the cubed root of 8 is 2. And I'm going to go ahead and get cosine of, what if I plug in k is 0? Well, if k is 0, then I just have 2 pi over 3. No big deal. Comma. 2 times. Now it's time for k to be 1. If k is 2 pi over 3 plus 1 2 pi over 3, which will be 4 pi over 3. Comma. And then all I need to do is one more, because I need 3 answers for a cubed root, 4 answers for a fourth root, 2 answers for a squared root, etc. So I just need to go 1. K is 2. Now this is 4 pi over 3 plus 2 is 6 pi over 3. Wait a minute. 4 pi over 3. What'd you say? Oh, thank you, thank you, thank you. How'd I miss that one? Yep, I didn't multiply 3 times 3 is 9, did I? Okay. Lo siento. I thought that was a little too easy. Adam just caught that I didn't get my denominator right when I multiplied 3 times 3. So the idea is still the same. I just got that multiplication off. Let me go ahead and get my cosine plus I sine ready. So in this case, I think I might get a common denominator to make my life a little easier. Instead of 2 over 3, let's change this to 6 over 9. Because then I can go ahead and combine my like fractions. Okay. That might be a little easier. So my first one is 2 pi over 9, not 2 pi over 3. There we go. My second one, plugging in my k to be 1, or my n to be 1. That's 2 plus 6, which would be 8 pi over 9. And then when I go to plug in my 2, there we go. That'd be 12, and 12 plus 2 is 14 pi over 9. Now, if they wanted us to write those in standard form, we totally could. We could plug into our calculator, and we could bring the 2 in, and we could get some decimals if they really want them, but that's enough. That's enough. That's enough. Kiddos, as you peek at homework, there is, I think, number 89 and number, what was the last one, 93? I think it was 93. That needed also roots. I'm not going to do both of them necessarily right now. They both needed roots. I can peek at it real quick and remember. It was number 89. I remember that. The fourth root of 16. And I believe it, number 97, I think, was the other one that you guys needed to do. Technically, with number 89, I know that you're like, wait, no big deal, except the problem is the fourth root of 16, we would say up until this point, I don't know why my smartboard's being dumb, would just be 2 and we would be done. But actually, all of this work says that there are more than just one answer to this type of problem. Because we would rewrite this guy, 16, to be 16 plus 0i. And all of a sudden, we can change this to be a complex number into trig form, which would be, I think, 4 times cosine of 0, 16. You could do cosine of 0 degrees plus I sine of 0 degrees. If we were to go into trig form, my whole smartboard started being weird again. Did I hit the zoom button? Anyway. And so then you could do this whole process of having to take the fourth root using what we just did. But the long story short, guys, is that there's not going to be one of these on the test tomorrow, number 89. And number 97, there's not going to be one of those either. This is similar. You would have to subtract the I, 0 minus I, and then take a fourth root of both sides. They are odds, so you can check out CalcChat. You can get down what you need for those ones as far as showing it as being attempted for the homework, but that's okay. I'm letting you guys know number 89 and 97 is not a big stressor, so get it in your homework at least attempted, peeking at CalcChat, but don't stress as far as needing to fully comprehend those two, all right? You guys have your test review up. You have formula cards to start pondering or thinking about, et cetera, et cetera, et cetera. I think I actually have some random blank 3x5 cards in my purse, ironically enough. I don't remember how I found a stack of them, but I did the other day. So I'm going to put those at the front of the room, so if someone does want to come up and grab a 3x5 card and start filling it out, that would be totally okay. They do have little, like, pink fuzzies on them, if you guys don't mind that. But they're blank 3x5 cards. If you guys want to grab one and start making one of those for tomorrow, you totally can. Remember, I'm not giving you any formulas on the test tomorrow. I am going to take a quick second, and I am going to peek at the test itself. All right, kiddos. If you want, you can either do it in your homework spiral in the test review, or you can go to your notes. I am going to give you some specific hints about tomorrow's test and what's on it. I'm I'm quickly reminding you of your formula card. There's still some 3x5 ones up here if you guys want to grab one. I'm putting this on the recording also. If you just want to access it later, that's okay. Be like, oh, what did she say is on the test? But remember, you need to bring your calculator tomorrow, right? Okay. If it's a physics-y problem, you guys know what I mean, right? With ships or trees or... if it's a physics-y problem, be in degree mode. No problem. The only time you want to be in radians really is for the very last section. Section 6.5 with complex numbers. Otherwise, degrees should be totally fine. But just a heads up, you might need to change your mode to radians at some point. And if I were you, all of you right now, if you have your calculator, change it to degrees. Because it might have been in radians last night for homework, but the test is going to mostly be degrees. So change it to degrees now if you have your calculator. I'll say it again tomorrow at the beginning of the test. Just to remind you guys, because it has been a while with Christmas break, you know when you come in, you're going to put your phones up in the chart, right? You're going to have your notes and your homework spirals be put in the 2 separate piles up at the front. And then at your desk, you're allowed to have your formula card, a blank piece of scratch paper, and a pencil, and your calculator, if I didn't already say that. And you are technically allowed to move around the room in the sense of spreading out to get away from people to have your own little space for the test. That's always an option, if you need just some space to not be distracted by people around you. As far as things on the test, we're in multiple choice right now, okay? Multiple choice. You're going to have to solve some triangles using law of sines or law of cosines. Remember, law of sines is really helpful if you have 2 angles at least, and law of cosines is really helpful if you have 2 sides at least. Unless it's ASS, but I might give you a hint about using law of sines for that. So you're going to have to solve some triangles in the multiple choice. You're also going to have to find some area. And there are 2 different area formulas. I'm going to tell you right now, you're going to need to know both of them. And if you guys didn't catch my hint from earlier, one is in the end of section 6.1 and one is at the end of section 6.2. If you don't find it in your notes, you might not have been here the second day of those sections, and so make sure you look in the book for both of your area formulas, but you will be able to use your calculator. For vectors, you're going to be adding vectors. You're going to be finding magnitude and direction of vectors from points, initial and terminal points. Components from points. You're going to be needing to make components also from magnitudes and directions using some formulas with maybe magnitude cosine theta, magnitude sine theta. Unit vector, make a star on unit vector. Look at your notes, look at your homework for unit vectors. That's one kids commonly miss. You're going to be doing some dot products. Maybe using the dot product in some different applications like section 6.4, plugging into some of those formulas. And then from section 6.5, this is finishing multiple choice. You're going to have to plot and find the absolute value of a complex number. You're going to have to go from standard form to trig form, or vice versa, or from trig form to standard form. And you're going to have to do a couple basic operations, but neither of them are roots. Could be multiply, could be divide, could be raising to a power. You have to use a couple of those operations for a couple different problems, but neither one are roots. Neither one are the very end that we just went over today. Okay, long answer. One long answer has to do with work. One long answer has to do with work and sliding something. Another long answer, actually I should say the other 2 long answers come from the 3 main types of vector word problems. So there are two more long answers. One's a bonus and one's not. That either have to do with something on a slope, something on an incline, which there's a special picture for that. Different forces being put together, kind of like the jet and the wind. Adding multiple forces together, kind of like the jet and the wind. Or the third type of problem that had to do with tension. So there are two more word problems. One of them is bonus, one of them's not. Either having to do with something sliding down an incline, adding multiple forces together that are at work, or tension. Okay, that's the test, kiddos. All right, there are some really basic things, but you need to know your formulas. There are some more involved things, but you're going to have your formula card. And all along the way, you're going to get to use your calculator. Okay? My Universal Studios people, be ready after school on Monday to take your version of the test. Please don't forget, but also please have fun tomorrow, because that's exciting for you guys to be able to get to go. For the rest of us, we're going to get it out of our hair so that the weekend we can have absolutely no pre-cal homework, and it'll be awesome. Sound good? Okay. With the test review, I know some of you guys spend a lot of time on, where'd it go? He ran away. He did run away. With the test review, I know some of you guys spend a lot of time on test reviews, and some of you guys do it very quickly. It kind of depends on your brain as to be honest, as to what type of focus you need to put into the test review itself. However, especially in this chapter, my advice to you would be to take special note of any of the types of problems I said as far as being on the test. If you come to a test review problem, make special note of what you're doing, what formulas you're using. Maybe make your formula card as you're doing the review to make sure you don't forget anything from section 6.3, 6.4, 6.5. I wouldn't spend hours on your formula card. Just make sure you have down what you needed for the review and or what is required for the types of problems that you put. Remember, no directions, no writing of the actual givens in the problems. You're just playing with them, using it as practice for tomorrow. Sound good? Okay, have your homework spiral done tomorrow, have your notes done tomorrow. You still have 3 or 4 minutes. If I were you, maybe come up and grab a card and be writing down. Be updating your table of contents in your notebook. Make sure you have your notes totally ready to get a 10 out of 10 tomorrow, because it'd be a shame if you don't have your table of contents, section 6.1 to 6.5. I'm going to meander around the room just in case there's something extra that you guys want to ask.